Hey, what's up guys? My name is Cherno and welcome to episode 87 of Game Programming. So last time we took a look at actually making these sub-sprite shapes, as I called them. I don't think there's actually an official term for that, so I just, sub-sprite shape, whatever. If someone asks you, then I don't know. I kind of made that up. That's not an official term. I don't actually know what they're called officially. But what we've got here is a way to create sprite sheets from sprite sheets. So in other words, we can grab an image file, and from that we can extract individual sprite sheets. In this case, strips for the player, of course. Because if we take a look at our player again, in our game directory here, you can see that it's actually divided into more or less 4 different sprite sheets, one each for each direction that he can actually walk in. So because of that, now we could of course make diagonal directions as well if we really wanted to, but because of that, we've had to kind of make up this method here. So now that we've got a way to actually extract these sheets, why not make a way to actually manage animated sprites properly? Now there are a few reasons why we wouldn't do that. Okay, we're gonna essentially do it now, but we're not gonna automate the entire process. And the reason is that, of course, animations require updates. The way that we animate things in our game right now is that we basically iterate through the frames as time goes on, right? It's an array, and we kind of flip through all of the sprites in that array as time goes on, time in the game, that is, as updates go on. Now, if we were to make a animated sprite, we would of course have to have an update method in here. And the thing is, how would we then update that sprite? That's kind of flawed. It's not absolutely flawed, but the thing is, if you look over here into our level, the thing that dictates updates here is, of course, these lists. And creating one for sprites would just be impractical. So we're going to kind of work around that and make something that is actually quite practical and quite powerful. So here in graphics, I'm going to make a new class here called animated sprite. Okay, and it's actually going to extend sprite. So you could go ahead and select it here like that, but I'm not going to because I could actually, but essentially it'll you just have to type in. Just have to type out extend sprite, okay? So in other words, make sure that animated sprite extends sprite, okay? So it's not letting us automatically. Okay, there they are. So we have to obviously use one of the constructors that we provided in Sprite. Let's take a look over here. We have a bunch of different constructors here. I think one that I'll probably want to use is an animated sprite is essentially going to instead of taking an animated sprite is going to consist of multiple sprites, right? And these multiple sprites, it should just be able to get them from a sprite sheet. So to make an animated sprite, all you really should need is a sprite sheet. Okay? And then of course we deal with this error because if it's a sprite, then it has to get all these traits. So let's just go ahead and look over here. Should it be a sprite? I'm looking, okay, so this has a sprite sheet, this has a pixel array. Yeah, okay, this is pretty much a sprite. So what I want to do over here is I'm going to, okay, so in size in X and in Y, as well as a sprite sheet. We have int, okay, so we don't have one that fits perfectly. So let's grab and let's make another array here in sprite. This will be we won't have in X and in Y, but rather what we'll have is a size and a sprite sheet. Okay, now you could argue that this is kind of impractical because, well, the thing is, we're not really going to use this for sprites, are we? It would be kind of, it's the only reason we'd use this is for sprites. So because of that, what I'm probably going to do is, I'm just thinking, no, let's keep it like that. Yeah, let's keep it like that. Let's make it protected though. I was gonna just make a default constructor here, but I'm not gonna do that. So the only way to do this is, well, technically all of these guys should be pretty much private or protected because we're all initializing them here. But we're just gonna make sure that this one is protected since it should only be used by animated sprite because there's absolutely no reason you do this otherwise. So let's set size equal to size, and let's set this dot sheet equal to sheet. Okay, and that's all we're gonna do. Oh, we should also, of course, set this dot width equal to width and this dot height equal to height. Okay, cool. Oh, sorry. To sheet. Oh, no, sorry, size. We want to set that equal to size. Again, this kind of assumes non-square sprites. I'm not sure if I'm happy with that. There's so many ways we could do this. Let's just make in width and in height for now. So we'll set size equal to -1, and we'll do what we did last time, which is we said last time that if oops, let me spell height properly. Well, we said last time that if width equals height, then let's set size equal to width. Else we'll set size equal to -1. There's actually a better way to do this. We could just simply say size equals width equals height. If true, size equals width. Else, size equals -1. So you could do it this way, of course, and that would just condense it into one statement here. Hang on a minute. That didn't work. Oh, sorry. My bad. Yes, we could do it this way. And let's get rid of this. So it's been a while since I've used this method here. But essentially what this does is it just condenses those two lines into one. So basically what it does is it sets size equal to a conditional property here. So in other words, what it does is it says that if this property is true, let's set size equal to this, else set it equal to that. So that's how it's going to work, okay? It's really simple, just a quick trick that a few of you might not have been aware of. So once we've done that, let's go back to animated sprite and let's actually just add int width and int height to the constructor here, so that we okay, I'm pretty sure that's the same constructor we defined. Is it? Yes, it is. Okay, great. So let's make sure that we do, of course, super it. And okay, brilliant. So what we can do now is add a few things that are only appropriate for animated sprites, such as frame, for example. Okay. Another one that we could add is, well, I'm thinking, no, that's probably about it. So we'll set frame equal to 0 to start off with. Other things that we might want to define is, of course, an update method, as I mentioned earlier. Another thing that we might want to define here is we want to define a get sprite method, and this will return our sprite here. Sprite might be something that's subjected to this class as well, because of course a sprite is a sprite. And let's see what else we need. I'm just thinking. Well, we may want to set the frame rate, of course. Set frame rate. And this isn't really going to be strictly a frame. It's not going to be strictly a frame rate as in frames per second, but it's going to be a rate at which we can control the thing. So I'll call it private int rate equals. We'll set it equals like 5 for default. So this dot or just rate equals frames. Okay, cool. So now that we've done this, we should do basically the same thing that we did in Player, which is we basically just said that if we were to advance this, we basically just said that if and we need to define a size as well. That's very important. Let's do that now, actually. So private int, I'll just call this animation size, okay, equals 0 to begin with, because this is incredibly important. So what we need to do is somehow get the amount of frames in this thing. I'm thinking, okay, yeah, no, that's fine. We'll have to actually make another one here. The more I'm making this, the more I'm thinking that animated sprite really doesn't have much to do with the sprite apart from width and height. So I know what you guys are probably thinking, especially those of you who are a bit more advanced, probably thinking, you know, does animated sprite really have to extend a sprite because it's just so much different? But I'm probably just going to leave it at that for now because, and the reason for that is because I want people to be able to set any sprite equal to be an animated sprite. And that, of course, works through inheritance. It more or less it kind of more implements a sprite than extends it, to be honest, because we're overriding like all the methods. But anyway, so we need an animation size, and we're probably going to specify that here. So animation size, and this is more of an animation length. I might call it. In fact, I'm just going to call it length. Okay. So the length is the amount of frames that we have in our animation here. So I'll set length equal to 0 to begin with. In fact, -1 because 0 is an invalid value. So as in it's invalid, and we can't possibly have an animated sprite with 0 frames in it because otherwise it's just non-existent. So we want to make sure that we throw an arrow if that happens. Okay, cool. So let's make sure that we set length equal to length. So of course this dot length equals length. And over here we want to say that if frames is actually greater than length, yeah, we want to obviously reset frames back to 0 because otherwise that's a problem. Or in fact, just to be smarter, well, let's see. No, we could just do frames plus. It doesn't matter which way you do this. You could do it the other way around. So in other words, if frames is less than length, frames plus plus, else frames equals 0, but it doesn't matter. And by frames, I really mean frame. Okay, cool. So what that's going to do is advance our frames. And what we need to do now is find a way to actually get a specific sprite in a sprite sheet, okay? Because the idea here is that we want to set sprite equal to an appropriate sprite here. So out of the sheet, I don't think we've got a get sprite method from here, don't we? Okay, let's make one. So public void get sprite, and public sprite get sprite. And what this will do is extract a single sprite out of our sprite sheet. So the way that we're going to do this is we know the size of sprites, don't we? So we just need a simple for loop here. The thing is, we might be creating new sprites every time. That might not be the most efficient way to do things, unless we do it statically. I think we're going to do it that way. So let's make an array of sprites called sprites, essentially, okay? And what this will do, we'll change public sprite to be an array instead of just one sprite. And what we're going to do here, especially in the subsheet, we might add this into the other sheets later, but this is the subsheet creation. What we want to do is as we take each sprite out of this array, we want to pop it into this sprite array, okay? In fact, that kind of even makes this a bit redundant here, because instead of setting all the pixels, we can just do this, but that's all right. We'll set it that way as well. So for int, this is actually this is quite simple to set up. So for int, we'll just go with y0 again. Y0 is equal to 0, y0 is less than, how many sprites do we want to deal with? Height, so I believe height is referring to the parameter, which in our case is the number of sprites rather than the number of sprites vertically rather than the number of pixels vertically. And we'll do the same thing for x. And of course change this to width. So that should just iterate through all our sprites. And all we want to do here is we want to create a new sprite. So let's make a sprite equal new sprite, and let's see what kind of constructors we have here. So we have an inside, let's see if we've actually got a way to do this through a pixel array. Not exactly. Okay, I'm just going to think about how we're going to do this. I think that we're going to have to make one that deals with a pixel array, but let's deal with these pixels first, okay? What we want to do is out of these pixels that are now in the sprite sheet, we want to kind of take a section of those pixels and add them into the sprite. So again, we're kind of cropping pixels again. It's going to be quite a lengthy episode, isn't it? Anyway, okay, so in that case, I think we probably won't be able to do it this way. We'll have to actually do it through pixels here. So because of that, I'm just trying to, this is going to be quite a difficult method to implement into a universal thing. Let's see. No, that's fine. We'll have to do it this way. Okay, cool. So this will iterate through our entire sprite sheet again. This is what we'll probably move this in here in a minute here, but I just want to make sure that you guys get how it works, just like that. Okay. So the idea here is to the thing is we're going horizontally here first, so that actually works really well for this. All we need to say here is we need to construct first of all a sprite array here. So no, I think a smarter way of doing this, to be honest, there's quite a lot of ways you can do this, but I think a smarter way of doing this would probably be what variables haven't we used here? I'll just make it ya for ya equals 0, and then ya is actually going to be less than the number of sprites we have vertically. Yeah, this will probably be a bit faster as well. Although speed really doesn't matter too much here since this isn't a continuous operation. So I'll explain what I'm doing in just a sec. Make sure that you of course use the correct variable names here. We're actually going to move this for loop into that for loop. And the way this is going to work is we have a quadruple for loop here. I don't think we've ever done that before. Basically these are going to iterate through our actual physical sprites. So in other words, height in this case is of course equal to 3, since we have 3 sprites here, right? 1, 2, 3. And width in this case is going to equal to 1, since we're extracting just the, you can see over here that we're extracting just 1 here. So of course, width is 1, height is 3. So for each of these sprites, it's actually going to individually select them and put them into a pixel array. And the way we can do that is just under here, we're going to actually make a pixel array. I'll call it pixels equals new int, and this will be the width and height of an individual sprite. So in other words, sprite size, I believe we did make them square for now. So sprite size times sprite size. I think I might make a class in the future that's just to do with sizes, because we seem to be putting int width and int height everywhere, and coordinates as well. That could be much cleaner if we actually make a class that just has these 4 integers or these 3 integers. Okay, so now we've made a new pixel array. What we need to do now is we need to first of all populate that pixel array. So pixels make sure that we use these new ones here. So x0 plus y0 times our sprite size is actually going to equal the sheet's pixels, which are, oh great. No, let's not call these pixels. Let's call these sprite pixels. Sprite pixels, okay. Sprite, because we've already got another one called pixels, is actually going to equal pixels, and these are the actual pixels of the sprite sheet, not of this new array that we're making, like a sub array, is actually going to equal pixels. Now, we need to make sure that we offset it by which sprite we're up to in the sheet. So in that case, that's relatively simple to do. What we'll need to do is make sure that, we also include these. So it's pretty simple, since these are in type precision and these are in pixel precision. So let's pop in x0 plus our xa, which is in sprite precision, and because it's in sprite precision, make sure that we actually multiply it by sprite size to get it back into pixel precision, since in a pixel array we're dealing with pixels. Same thing for y plus ya times sprite size, and make sure that we also of course multiply it by the sheet's width, which is just width. Okay, but I think we put sheet width here. That's probably not. Oh, okay. Oh, this is the sheet. Okay, so make sure that oh, okay. So we're not getting. Okay, yeah, we don't need to go sheet.width because that's this sheet's width, and when we've already extracted it out of the sheet. So we just want to deal with this one. Again, these are just subtle errors that can really ruin your day. So make sure that you logically think about this as well. Okay, cool. So now that we've done that, we've got a pixel array, and that pixel array contains just one sprite out of the sprite array. Okay, and this will actually be a universal method that will work, because what we're doing with this essentially here, and with this, we're kind of using a modulus by not using a modulus. So in other words, we're saying that when you get to the end of the sprite, just take one area out of the sprite sheet, just one square area. which is defined by sprite size, okay? So now we need to make a new sprite out of this pixel array. So we'll just pop in sprite pixels, and we'll give it a width and height. We have to give it a width and height. So in fact, we don't, since width is equal to height, we'll just make it sprite size for now. But again, I do want to keep this universal, so I'll make both of them. So now let's create a constructor for that. And this is going to be like the easiest constructor ever. So size is going to equal, we'll just copy and paste our this size argument here. So if width equals height, and this will be pixels. So that's what size is going to equal. So otherwise though, we have to make sure that we actually do set this dot width equals height, and sorry, that was probably the stupidest statement I just wrote. Let me just fix that in a minute. This dot height equals height, and of course this dot width equals width. And the thing is, one mistake like that won't actually affect it, because this is square in this case. So this is how a lot of people make a lot of errors. So anyway, once we've done that, make sure that we do set this dot pixels equal to the pixels that we specify. Okay, cool. And that should actually work properly. So this is a pretty easy method constructor where we don't even have to load anything, because it's that simple. So yeah, okay, cool. So back to no, hang on, back to sprite shape for a minute. Where are we? Oh, get sprite. Okay, cool. Oh, okay. So now that we've made this sprite, we need to actually add it into our pixels. So let's see. We need to add it at the end here. So we need to first of all keep track of which frame we're adding. So we'll make int frame equals 0. Every time we iterate a frame, we'll add 1 to frame. And then at the very end of this, so at the very end of these two, we need to go ahead and sprites frame equals sprite. Okay, and in fact, what's wrong with this? Oh, great. Okay. So I think, oh, we could just move this down here, really, can't we? Okay, cool. And we're adding to that. In fact, I'm probably going to delete this frames plus here and just put frame plus into here, which basically means that as soon as it adds a sprite into the sprites array, it's going to just iterate frame. It's going to add 1 to the frame, so that next time it will be it'll be different. Okay, so that is that is quite a complicated method. I'm not going to lie right now. I had to stop and think there for a minute because I'm doing this off the top of my head. So it's not guaranteed to be correct, but I think this is right. It looks right to me right now. So now what we should do over here is just return the sprites. So first things first, let's go into our animated sprite and set sprites equal to, okay. Let's also make sure that, oh, okay, sheet is stored in super, right? Where's our sheet? Yeah, sprite sheet is stored in the super class. So sprite equals sheet.get, what's it called? Is it private? I think it's private. Okay, it's private. Let's change that to protected. So a sprite equals sheet.get sprite at index array frame. Now, this should essentially be correct. In fact, I'm thinking we might not need length here at all. Nah, I think we'll keep it in. Okay, I'll quickly explain what I mean by that. The reason is, of course, we know the length of this sprite array because sprite array. If we go to this, there is a dot length field, and we can find out the length. But the thing is, even if your sprite array even if your sprite sheet might have 20 sprites in it, you might only want to use 10 for the animation. So you might want to crop it. So that's the deal. Also, one thing we want to find out is just to handle this error, or at least tell us that there's an error, we'll go ahead and say that if length is actually greater than sheet.getSprites, it should be called getSprites, dot length, we'll change that in a minute, dot length, then we'll just go ahead and go system.error.println error. This is like the first error we've ever printed, isn't it? Length of animation is too long, or something like that. So let's change this get sprite method to be in sprite sheet to be get sprites rather than get sprite, and I think we're done. Okay, so that's pretty simple. Okay, in this class, of course, in sprite sheet we have to do some fancy things, and this rate here needs to be probably so if so time plus plus, we need to make sure we make one for time. Private int time equals 0. So time plus plus, and if time mod our, you can use and as well, but time mod our rate is equal to 0. Yeah, equal to 0. Then we'll do this stuff. Okay, and that's actually going to loop through our animation. Now I'm not going to test this right now because there's quite a bit more code that we want to write. But I will make sure that it is iterating through these. And the way that we can do that is, let's go into player, for example. And in player, I'm actually going to make a new animated sprite. So private animated sprite test equals new animated sprite. And I'll take sprite sheet dot player down. Now the width, I think this is the width in anime. Is this the width in, I think it's that, yeah. Oh no, 32. And the length, of course, of the animation is 3. And let's go ahead over here. We need to make sure that we update. So test.update. And all I want to do here in animated sprite is just print out the frame. So system.out.println will print the sprite plus frame. Okay, and that will give us a good indication of whether stuff is working or not. So let's run that. Okay, so we get an array index out of bounds exception probably. Yep. Okay, so we got an array index out of bounds exception. Let's find out whether. Sorry, this episode is going to be very long. I'm really sorry. I probably should have dived into this, but let's see what's out of bounds first of all. Is it pixels? No way to tell. Is it this? Hang on. I wish it would tell me the exact. I think it's okay, so it's happening from the player down, and it's happening right over here. Okay, so this is fantastic. Now we need to find out which array is out of bounds here. So that's equal to 32 times. Oh, hang on a minute. If y0 is 32. Oh, that's fine. Yeah, that's fine. X0 is 1, that's 0 times 30. Okay, so this gives us 0. This gives us 32 plus 0 times 32, so this gives us 32 times width, which is 32. This should be fine, I'd say. So this is probably where the error is. So sprite size is equal to 32. Y0 is equal to 32. And that's fine as well. So why is that giving us an array index out of bounds exception? That should be fine. Let's diagnose this quickly. So let's set let's just print out the. I'll print this out as an error so we can identify it quickly. So let's print out sprite pixels dot length. And let's print out pixels dot length. Whoops. Okay, so let's check that out. All right. So the length of this is 1024. Let's bust out our calculator. So if we just go standard here. So 32 times 32 is 1024, which is correct. That should be the size of that. And our sprite sheet should be 32 times 3 times 32, which is 3072. So that's fine. So clearly something is wrong with our actual for loop here. The arrays are properly initialized. So width is 1, height is 3, height here is 96. Oh. So here's the problem. Height here is 96. Width is fine. So this height is the height of not each individual sprite, which it should be, but rather the actual heights here. So this should be set to sprite size, and this should be set to sprite size. Okay, so pretty subtle, but make sure that you set that up correctly. And let's play it again and see what we get. Okay, so now we have a null pointer exception for sprites. So sprites equals null. Okay, we never made a sprite array, did we? It's up here. So now let's make sure that since we do know the length here, let's set sprites equal to new sprite. And it will be, let's see here. So I think we do know, right? Width times height. Because this width is, yeah, that'll give us 3. Okay, that's correct. So let's try that again. Okay, we crashed again, but I think so frame 1 here, frame 2 here, that worked. Then as soon as we got to frame 3, we crashed. Oh, I see. Oh, okay, animation length. Okay, that's makes sense. Okay, because we started at 0, so make sure this is equal to. Let's run that again. No, that still crashed. So frame is equal to 3. Frame is greater than or equal to length. Frame 3, 1, 2, 3. I'm thinking that the thing is when you specify frames though, frame numbers are kept as. You want frame numbers to be 1, 2, and 3. You don't want them to be 0, 1, 2, do you? Or does frame 0 work for you guys? I don't know, because in video or whatever, the first frame is frame 1, not frame 0. So I'm just thinking if you guys want it to be like that. I don't know. Because the length, what's the length that we set? The length we set is 3, right? Okay, so we set the length to be 3. And frame here is equal to 3. That should have set frame back to 0 actually. Huh. Let's just run that again. That should be setting frame back to 0. Because it says if frame is greater than or equal to length. Length is 3. Frame is equal to length in this point. Unless it does that after. Okay, we could add this here, I guess. Okay, so now you can see here, if I stop this, we are looping through frame 0, frame 1, and frame 2. And that is giving us different sprites, as you can see, for each frame. If you enlarge this quickly. In fact, let me quickly go to window preferences, general, no, maybe not general. Hang on, yeah, it is in general. General editors, text editors, no, it's in appearance, colors and fonts. Sorry, it's been a while. So for the console, where is it? That's the editor font. Where's the console font? It's supposed to be here, isn't it? Maybe it's in debug. Yeah, console font. Edit, I'm just gonna increase that to be about 16. Okay, so, yeah, okay, so we see that for frame 0, as you can see, the actual identifier for the unique instance of sprite is 69E1 or whatever, 69 we'll call it. For 1, it's 59, and for 2, it's 121. And as you can see, it goes back to 69. So what we can see just by reading this text is that it is looping through a bunch of different sprites. Now, because you guys probably want to see what that looks like on screen, and because it's actually going to be a one-line command to get it to print on the screen, to update the sprite here, all I'm going to do is, we are updating the sprite here. So all I'll do is I'll actually set our sprite right now. How do we set that? So we set it to play forward, and depending on which way he walks, we actually set it differently. So just before we render, let's set sprite equal to test.getSprite. And that should, if we go to this, that returns our sprite. So let's take a look at that. Okay, we crashed again. What's null here? Sprite, oh, sprite's null. Okay, hang on a minute. I don't think we set that correctly. In animated sprite, so sprite equals, okay, so make sure we set a default sprite. So sprite at the moment, sprite should equal sheet.getSprites 0 to begin with. Otherwise we get a null error here. Okay, so you can see right now that we've got our character here and he's dancing. Okay, and you can see that he's dancing. He's a bit off center as well, but it doesn't matter. He's dancing here, he's pretty happy. You guys can see how good my drawing ability is, and we're actually animating our player by using essentially in the player class two lines of code, okay? And one to actually make him, okay? Instead of all this animation stuff. So that simplifies things a lot. And I hope you guys enjoyed this episode of game programming. Man, this is a long episode. This almost felt like a 3D game programming episode because this is usually what they're like. But I hope you guys took something away from this. If you did, please hit the like button. If we do hit 300 likes, I will make 2 episodes in one day. Otherwise, if we hit 200 likes, I will release an episode tomorrow. So please hit the like button if you guys enjoy this video. And I'll see you guys next time. Goodbye.